Hello everyone. After many months of researching, experimenting, designing, and building, I am proud to finally show you the finished Nixie tube clock. Well, almost. As you can see, there's no casing for this yet. I still plan on putting some kind of acrylic around this. But all of the hardware from like an electrical standpoint is totally finished. And I am very excited to turn this on and be able to show you. So, first off, I'm going to turn it on now. So it uses a USB plug on the other end. On the end that actually plugs into the clock, that's a like a DC barrel jack type thing. So you can power this from like a normal AC adapter, or if you have one of these cables, you could plug it into just like a normal USB phone charger, as long as it's 2 amps. It does technically use like 1.1 amps, so anything higher than 1 amp, but honestly, you'd be hard-pressed to find anything that is 1 amp these days. Those are really old usually. So anyway, I'm gonna plug this in now. I'm hopefully gonna get it the right side on the first try. Okay, there we go. So now that it's turned on, you can see the decimal points in the tubes going back and forth, and that is it connecting to the internet and getting the local time from a time server. And as you can see, it has now synchronized to the correct time. Well, I guess the correct time as of recording, you're just gonna have to take my word for it. But it is 7:58, 59 here right now, which is, oh, actually, yeah, I can show my watch. So it is the correct time. So that's pretty cool. Yeah, so these 4 lights here, the one on the left shows when it's on, it's PM, and when it's off, it's AM. So right now it is 7:59 PM, so that light is turned on. And then these 3 lights here, they show which function it's currently showing. So this first light is turned on, which means it's showing the time. And if I push this button here, it'll switch the function. So now it's showing the date. It is September 25th, 2024, as of time of recording. And then push it again. It's connecting to the internet again, as you saw on the little loading decimal points. And so this is the weather. So the left one is the temperature. It's 64 degrees outside. The middle one is the humidity. It is 98% humidity. And this one is the percent chance of rain, which says 99, but since it can only show 2 digits, I programmed it to be capped at 99, so it could be a 100% chance of rain too. I just so happen to be recording this in the middle of a hurricane, so yeah, it's pretty humid and rainy outside, but I guess it was like a perfect time to show this off then. And then if I push the button again, it'll turn off. This is just like a power saving mode, or if you just want it to turn off. And then push the button again, and it'll show the time again. So it will automatically turn off every night between the hours of 11 p.m. and 7 a.m. because these tubes, you know, they don't last forever. They do last a very, very long time, but the longer they're on, the higher chance they have of suddenly breaking. So I just have it turn off at night because I'm not going to be looking at it anyway, and it helps extend the life of the tubes. Speaking of extending the life of the tubes, so you can see every time it switches the function, it does this cool transition effect, right, where it kind of shuffles the numbers randomly and wipes it across. Well, that's also secretly a feature for tube maintenance, because these Nixie tubes, if you display one number on them for too long, what will happen is something called cathode poisoning, where all of the other numbers that it shows will no longer work. So for example, when it's showing the time, this number is going to be 0 most of the time, and then 1 some of the time, but it's never going to be any of the other numbers. So when you push the button and it does the transition sequence, if you look really closely on any one of the given numbers, it'll show every number exactly once. So if you want, you can like slow down the video or something and see. If you just look at one tube, it will show every number in the sequence randomly. And it does show every number to make sure that every number is being used so that no number will end up with cathode poisoning. It does the transition more than just when I push the button. I also have it programmed to every 15 minutes automatically shuffle through all the functions. And I do that just, first of all, to show off the functions, but its real secret primary purpose is to make sure that that cool transition sequence is being run so that all of the numbers are being displayed. So next, I'm going to show off the PCBs, the circuit boards that I soldered everything on here to. This is what took me so long to make this video. I had to wait for these things to come in, and then after they came in, I had to solder like a million little solder joints to put them all together, and it wasn't without difficulty. I unfortunately did not completely get the circuit board design right the first time. One of the problems I had was the holes for the screws were too small. I had already had these screws. I pulled them out of a different device and I was going to reuse them, but I guess I measured the screws wrong or something, and the screw holes were the wrong size. And also the hole for the button was the wrong size, but that one actually wasn't my fault. That's because the datasheet lied to me. But anyway, I took my girlfriend's Dremel and I just made those holes wider. So that was, that ended up not really being an issue at all. Let's see. There was also a problem I had with this connector back here. Actually, so I've explained this in past videos, but I'll go ahead and re-explain it here. The board is divided up into 2 layers. There's the bottom layer and the top layer. And the bottom layer is where you have the Raspberry Pi Pico, the buzzer, the leads for the smaller tubes, the high voltage driver, and the power input. And then that uses this connector back here. Let me see if I can get a good angle on it. Yeah, it uses this connector to send all of that power and to send the 2 I2C signals to the top layer so that it can communicate with these 2 chips here to set the tubes to their correct values. But anyway, when I was installing this connector that electrically connects the bottom and top layers, I was having problems because I made these through holes too small. But as it turns out, despite the fact that I made them too small, I could just really shove the connectors in there, and then it ended up working. So that was a problem solved. Another issue I had was I accidentally made the leads for these smaller tubes backwards. So that's why you can see the leads for these tubes are all taped up and they kind of cross each other, because I couldn't just turn them 180 degrees because they only show light on the front. So I just had to cross the legs and wrap them in enough Kapton tape that hopefully they don't short against each other, which they haven't so far, which is good. Yeah, then there is the tubes themselves. So one of the features, I guess, that I wanted to design in was, instead of soldering the tubes straight to the PCB, I wanted to have these pins, these sockets, so that in theory, if one of the tubes breaks or stops working, instead of having to take the whole thing apart, desolder the old tube, and then solder in a new tube, all you have to do is literally just grab this tube, pull it straight out, and then cut the leads to the correct length, stick it in, and then it starts working again. Except it turns out it's way harder to get a Nixie tube into these pins than I thought it would be. These sockets like, even if you cut all of these leads to exactly the same length, something about them, they just like don't want to go into the holes. And so that ended up being super difficult. Honestly, if I were to do this again, I might just solder it in because it was almost as much trouble anyway. But anyway, I don't know. It was just like something that I thought would make things easier and ended up making things harder. But now I know, this was my first time doing it, so I think all things considered, this was pretty good for a first attempt. In addition to all of the hardware bugs that I fixed, I also had to fix a lot of software bugs because as I was waiting for these circuit boards to come in the mail, I wrote most of the software for this thing just because I didn't really have anything else to do. But when I loaded it on here after the hardware was finished, it almost worked the first try, and I was really impressed with myself for that. But I still had a couple bugs that I ended up being able to fix over the past few days. So I won't go over all of the bugs because most of them aren't that interesting, but one of the funnier ones that I wanted to tell you about was, for some reason, when it showed the date, it would show the year as 1994 instead of 2024. It ended up just being like a number format conversion issue, but I thought that was a pretty hilarious bug that I had to fix. It's probably closer to the date that these tubes think it is than what it actually is. But anyway, so that's really everything that I wanted to talk about this clock. That's kind of all I have to show off for you today. Like I said, really the only thing that's left is to create this acrylic enclosure, which will go over the bottom part. So I'm going to do that using my local library's laser cutter, but I've been having trouble reserving that, so it's going to be several weeks before I even have access to it. But once I make a casing for it, then it will be truly complete, and I think I'll make one final video about that. Oh hey, there it is. It's doing the 15-minute cycle thing. I was just talking about that. That's good because I won't have to cut to that later. But anyway, so like I said, I will make an acrylic case for this, and then I will make one final video, and then that'll be it. It'll be a complete finished product. And if anyone else wants to make one of these, in the description of this video, I'm going to be posting all of the design files that I made and all of the code that I wrote. So you'll be able to find the design files for these circuit boards, a part list, all of the parts that you'll need, and all of the Python that I wrote to run this program. Oh, and for the PCB, I'm going to fix all of the issues that I described so that you don't have to modify the boards in the same way that I did, but that might not go up right away, so if you're interested in that, just keep checking the description. I'll have those design files up eventually. And then hopefully you'll be able to kind of figure out how to assemble this thing from all of my videos. That being said though, if you are watching this video and you know me personally and you want me to build you one of these, I could totally do that. You could commission me to build one for you. Fair warning though, it's not going to be cheap. The raw material cost alone for this is kind of high. Like these tubes, they don't make them anymore, so they're not cheap, and the circuit boards were not cheap to manufacture either. It's I might have to charge you like $300 or more to make you one of these, but I'll totally do it. So like I said, any of you that know me that is watching this, feel free to reach out. Yeah, so that's all I have to say, really. Thanks to everyone who has watched my progress up to this point. I really appreciate it, and I hope you found this just as interesting as I did. As for the future of this channel, like I said, I will upload one more video of the truly finished project for this, and I might in the future post about future projects that I do, because I do projects like this all the time, and I find them really fun, and I find making these videos kind of fun, as much as I hate to admit it. So, if you're interested in just kind of old technology shenanigans like this. Stay tuned for future videos. Subscribe, I guess, and I'll see you later. Bye.